iso contours of the system as a whole. And you can also, this is the velocity vectors for the rotational velocity that is also created that you can see. So to do this, let's see. Where's the terminal? There's the terminal. All right, so here is a folder containing all of the files from a successful Lorene run. And litbin right here is the executable that you're going to want to use for these plots, which simply just make litbin and it should work no problem. And we're going to want to also use these resu underscore bunch numbers files. And each of these numbers corresponds to the different separations that you generate throughout the entire run. So to show what this does, and then resu underscore say 6.5. So you're at 65 kilometer separation. And do you want to draw the boundaries of the various domains? Yes. So just y spits out some numbers. Wait a few seconds. Oh, is this one?
So what it's doing right now is actually reconstructed it stores coefficients, and it has to reconstruct the full configuration at spatial locations.
Right. And then it asks if you want to see graphics lists. I'm going to put this over here. And so, question mark? And so we want X window, which is the first choice in the interactive devices.
Well, it pops up the screen.
Okay. And there's a nice, pretty cool plot. And you just keep regenerating the sequence. And different plots show up. There's a whole, in the script, there's a whole list of plots that it is supposed to be creating. We commented out a few of them because a lot of them don't look pretty cool for demonstration purposes, but some of them do, so you can just keep going through them and it's kind of the same. That one they're farther away. You can just do this forever. There's just one of the stars. So, yeah, you can just do this forever and ever and you'll generate a bunch of different plots. That's pretty much all there is to it. So, where did the thing go? There you go. Okay, so that's litbin. Pretty simple.
So we're actively working this summer to further the development. There's basically, to anticipate the question about open source. This is already an open source code before we even got to it. So certainly anything we develop is kind of instantly open source. It might just not be posted in a public forum until we remember to go do it. But there's basically nothing secret involved in this whole thing. We uploaded the one file that we recommend patching for the standard Lorene release is up on the Google Drive here and is just a one-line fix. We're actively developing some of the tools basically to improve stability. Right now, out of the box, there's a pretty good chance that if you try equal mass run for reasonable parameters, that you should be able to get Lorene to typically converge. Lorene knows that if the two components have equal mass, then the center of rotation is dead center, and it can use symmetry to make its life much easier. Unequal mass configurations, we found through trial and error and more trials, that the lower the mass, the more stable Lorene tends to be. For this reason that you saw the figure, you tend to get random steps that miss, and if you're not careful, they crash everything. So the lower the masses you want to use, the more likely it is to work out of the box. Knowing that this is a weakness of the code, but also that the code just never takes very long to run, up to a day in serial. We're currently working this summer on routines, like I mentioned, to scan in mass or radius. Start with a configuration you know it will stably be able to produce pretty much every time, and then let it form a relaxed binary, and then gradually change the various parameters for that relaxed binary up to the final values that you want. The code iterative scheme is much happier when things are near equilibrium, and much less happy as it seeks equilibrium from further away. I believe the plan, probably starting sometime next academic year, date TBD as these things always are, is to do the same kind of thing for the black hole neutron star routines. They're already in place, but kind of coming up with the user manual for using them is more required there. The documentation for the black hole neutron star cases is much less advanced than the binary neutron star cases. And even there it needs some obvious work. Oh, sorry, that was point number 3. We're going to be generating a library of binary neutron star initial data. As soon as we can figure out how to host it without filling up our Bitbucket repository, we'll be happy to post it. It's easy to go above 2 gigabytes or whatever if you're not careful, so we just need a better thought out data solution. But the intent is to obviously post all this publicly. We just need to handle the architecture side properly. Lorene has routines for magnetized neutron stars or spinning neutron stars. This isolated spinning neutron star codes are basically already in place. You could think about putting spinning neutron stars into binaries. I don't know what the timescale is for self-consistent magnetized or spinning neutron stars in binaries, though it's fairly easy to picture how you could possibly put in non-fully self-consistent, so background type magnetization or spins, on top of existing solutions. But those are kind of future work. The goal by the time scale of this summer is to basically have the routines ready where, for a reasonable set of masses, an existing equation of state or one equation of state model that fits within the existing schemes, a separation where the binary is still well defined, it should be possible to basically, by modifying a few ASCII files and fairly minimal work, get a reliable, binary neutron star initial data configuration where you can be confident that it will not crash at some random step along the way and make you keep tweaking parameters. So we're already part of the way there. We've generated many. Our goal now is to basically take the steps that allow it to be reliable and as robust as we're going to get. We have 5 minutes before the coffee break. So if people have questions or things like that, Eric.
Is there an easy way to take the output and put it into, visualize it using something other than Gplot, like Matplotlib or Visit or?
Yes. Okay, so this is something that we haven't done yet, but I have code on my computer that can do this. So Lorene has a standard set of codes to basically take a binary file and reconstruct the full representation. It's a C++ object-oriented code. So it's a fairly standard set of commands to essentially reconstruct the configuration from the data file. In the past, when I've done this, not being quite as expert with some of the graphics tools, I've had it scan over a 2D grid and basically output function values to reconstruct a 2D grid from it. Somebody who knew what they were doing with graphics could almost certainly use those tools to produce the graphics more directly and more conveniently. In fact, that's one thing we hadn't actually talked about here, but it's probably a good step for everybody, would be, come up with a front end that reads stuff out and give enough examples of how to then output quantities at points to allow people to understand the graphics side better to do what they want with them. But that part of the code it's a standard C++ thing. Once you learn the sequence of how to drill down to the call you want, the rest follows pretty natural. So yeah, we can definitely handle that this way. Roland?
Then we have already two pilots in the Einstein Toolkit, where we actually also building the init in core code with a handful of patches that's slightly different from what we were doing. So since you guys know what you're doing, would you be willing to contribute a documentation to that platform?
Yeah, absolutely. So yeah, all this stuff we're doing is intended to be public. To the extent that it's not public, it's just because we haven't had time to kind of distribute it properly yet. But yeah, all this kind of stuff is public. Lorene is tricky. We found out the hard way. There are additional issues that came up. So we're using the bin_star routines right now. There's a couple of different implementations of Lorene. Binaire, the French words versus the English words. There's also a binary class. As far as we can tell, the binary class has a weird bug where they, I'm pretty sure that some parts of the code rotate one star by pi radians to align the axis one direction, and certain parts of the code assume it's facing the other way. So there's a couple points where we probably have bug reports but no fix that we've had time to work on yet. But certainly the goal of finding this isn't to keep it to ourselves. So all of this should become public as we write things up. And we'll try to write it up in a way that gets as much feedback from other people as possible so that it kind of gets spread as widely as possible, as quickly as possible.
Was the overlay document shared with in the Google Drive file?
Oh, yes. So did everyone see a link to an overleaf document at some point? That's our running notes. Those are intended for public consumption. So if people are interested, I think I can't make people official collaborators without upgrading my overleaf account, but we can certainly do the link sharing so that anyone who has an interest can get full editing access to that document. And that document's just intended to be a community, or we can even host it somewhere else. We should have a community-based document that describes, how to use Lorene, how to patch it, things like that too.
Would you be willing to make that part of the documentation of tech file for Lorene?
Oh, absolutely, yeah.
That's where it's officially going to be.
Right. Yeah, so we're happy to share it into whatever places are convenient at this point. So into the ETK is as good a place as any of them by far. So yeah. And I guess just a sales pitch. So apologies that we had no idea how to actually work out kind of a live demonstration with everyone today. As some of you may have found out, Lorene doesn't have a configure script that goes in front of make. So there's always a little bit of play around until you get it right. I will say that I've got up on the Google Drive. I've got a script for Macs running Homebrew that seems to be working fairly well. Maria did manage to find out that Macs apparently broke Xcode a bit in their last release. But that's not Lorene's fault. Macintosh apparently broke Xcode in their most recent one. But basically, there is if you're using Homebrew, then there is a local settings file, which basically acts you need that file instead of a configure script, so you need to do it by hand. But that should work for any Mac user, hopefully using Homebrew in a fairly recent setup. For Unix users, it's mostly finding a proper link to pgplot and laypack. Yeah, the statement I'd like to make is that if there's a compilation error that you can get using Lorene, I've gotten it before, multiple times. And we're happy to help people kind of get up and running so they can dabble it or use it, for actual Einstein Toolkit calculations too. So we'll be around all week and at this, all summer long. So if there's any questions, feel free to send it our way, and we'll try to help everyone get up and running.